Hello everyone. Today, I'll walk you through the steps to create this interactive Lua scripted monitor. As you can see, our little 2x2 monitor is displaying a custom colored map with zoom in and zoom out button, as well as a zoom indicator. We also have in the bottom right corner the arrow keys that will help move the map. At the top here we have the X and Y coordinates, and in the middle we have our position represented by this little dot. Notice that when we zoom in and move around, the speed at which we do so changes so that we can get around the map quicker when we zoom out and make more precise movements as we zoom in. The monitor also has a brightness input which controls the potency of the colors on screen. That's basically it for my little summary. Now let's get started. So, getting started. Let's first lay out the tasks that we're going to need our script to complete. In our onTick function, we need it to first input our touchscreen data, we need it to input our brightness, and input our GPS location data. Then, we'll define our touch sensing function as well as all the buttons on screen. We'll need to make the equations that change our movement and zoom values. And finally, we'll clamp the zoom value because we want to limit how far we can zoom in or zoom out. Now, moving on to our Ondraw function, our tasks are drawing the map, drawing the player, drawing the buttons, and then drawing the conditional rectangles that will appear only when those buttons are pressed to indicate a press. Alright, now that we have a good understanding of what we want our code to do, we can begin writing, and we'll start by making a microprocessor. Alright, now that we're in the workbench, let's go ahead and name our microprocessor something like Lua-Interactive-Map. And let's go ahead and make the width 3x2 because we're going to need 6 logic nodes. Once you have them all in there, go ahead and space them out on the processor, and now we can get on to naming them. The first one we can set to composite, and that will be our touch input. And with the second one, we could go and set it to video and set that to monitor output. The third one we can change to number, and that will be our brightness input. The fourth one we could leave as on-off, and that will just be turning our microprocessor on and off. And the last two we can set them both to number, and that will be our X coordinate and our Y coordinate inputs from our GPS sensor. Now in the logic editor, we can go ahead and place down a Lua block, followed by, we could take a composite right number block, put it right below, set the start channel to 5 and the channel count to 3 because we don't want to mess with the touch input channels, which are 1, 2, and 4. Then go ahead and place a numerical switch box, followed by the constant number of 0. Now let's go ahead and wire them up. So we can start by taking the on-off and plugging it into the numerical switch box, plug in the constant number of 0 into the off path, and the brightness will go into the on path. We can plug the output of that switch box into the first channel on our composite number right. Then we can plug the X coordinate into the second channel and the Y coordinate into the third. Now we're going to go up to the touch input and put that through our composite right. Plug that into the Lua script, and the Lua script video will go into the monitor. Now go ahead and click Edit Script, and we're just going to go and delete everything that's already here. Now we're going to go into Help, and we are going to paste the touch inputs, so the very top stuff that I'm copying down right now, just paste that into the function onTick. Now we're going to continue inputting our data. So the first thing I want to input is brightness, so I'll just set that to B, and that will be coming from our 5th composite channel. And we also need to put in our world X, which will be our 6th composite channel, and our world Y, which are our coordinates from the GPS sensor. Now, since we want our zoom to grow exponentially, we're going to have to make 2 variables. One of them is going to be zoo, and one of them is going to be zoom. We're going to set zoo to 5, and that's going to be the base for the exponential function 5 to the X. And zoom will be the X. Now, the reason we set zoom to minus 1.431 is because when you take the exponential function 5 to the X and you raise 5 to the minus 1.431, that actually makes exactly almost 0.1, which is the lowest that the zoom on the map can go. Now we're going to take 2 more variables, X and Y, set them both equal to 0, and these will indicate how much our map is moving up or sideways on the screen. Now head on back into Help, and you're going to copy the function that is in the middle, paste it same place in your script, and copy the isPressingRectangle command and paste it into the onTick function. Now you're going to rename the isPressingRectangle into isPressingZoomIn, and copy that whole command, paste it again right below it, and rename that to ZoomOut. You'll notice that right here I go about changing the values for where the buttons will be, and these are just specific to my monitor. If you want, you could copy these, but your buttons could be anywhere on your monitor. Now that we have our buttons defined, we're going to go ahead and write two if statements that will actually change zoom based on which one of them is being pressed. So go ahead and indent and start writing if copy paste is pressing zoom in, space then, and you're going to go ahead and enter zoom is going to be equal to zoom plus 0.01. Enter, and then you're going to write else if copy paste is pressing zoom out, same thing, space then, and zoom now will be equal to zoom minus 0.01, enter and end. So now what we have in code is if the zoom in button is being pressed, zoom will increase by 0.01 every tick, and if the zoom out button is being pressed, zoom will decrease by 0.01 every tick. And each tick in Stormworks is around a 60th of a second, so it'll go pretty fast. So next we're going to go ahead and do the same exact thing we did for zoom, but for the other 4 buttons on our screen. Just copy paste, and I'm going to rename mine to X plus, X minus, and same thing for Y. You can see that I go ahead and change my values for the rectangles to define the buttons. Now these again are on my screen. You could do them differently, or you could do them the same as I am. Again, we're going to have to write 4 if statements, so we're going to go ahead if copy paste is pressing X plus, space then, and we're actually going to increase, so we're going to set X equals X plus 0.75, and you'll notice it's going to increase X a little faster than zoom. Same thing, now we're going to go, actually I forgot to indent earlier, I should have done that. So we're going to go ahead and indent all of your if statements. Go ahead again, else if, and now we're going to go is pressing X minus, and now we're going to decrease X by 0.75. Now once you're done, just copy this over, and you're just going to replace all the X's with Y's. Now the thing is, we want to make our movement proportional to our zoom. So what we're going to have to do is we're going to have to multiply the 0.75 on each one of these if statements by a coefficient. And that coefficient is actually going to have to be zoo to the power of zoom. Except we're going to open a bracket and write zoom plus 1.431. And the reason we're going to do that is because, as you can remember, zoom started at minus 1.431. So then if we add minus 1.431 plus 1.431, we get a power of 0 on zoo, and 5 to the power of 0 is 1. Therefore, our zoom coefficient will never be less than 1. Now just paste that same coefficient to every 0.75. Next thing we want to do is make a clamp to prevent the map from zooming in further than 0.1 or further than 50. So if we know that zoo to the power of zoom has to be between 0.1 and 50, we know that zoom has to be between negative 1.431 and 2.431 if we do some basic math. So creating the clamp, we'll go about like making a regular if statement. We'll write if zoom is less than minus 1.431, then set zoom equal to minus 1.431. So it'll never go below that value. We're going to type end, and another if statement. If zoom is greater than 2.431, then zoom is going to equal 2.431 and end. Moving on to the Ondraw function, we're going to go to help, and you could see we're actually going to start by drawing our map. So the first thing we want to do is we want to set all of our colors. So right here is just the example ones, and I actually have my own colors that I'm going to import and paste right here. So you can see I have all my red, green, and blue values, and the last 4th value of every color is just going to be the transparency. And as you can see, all the RGB values have a times B associated with them, and the B is actually brightness from earlier. So that will control how bright that color is. Next thing we want to do is actually draw our map. So we're going to go into help, and we can copy paste the draw map command from there. I'm just going to write mine in. I've already started. So I'm just going to write in the basic values for now, X, Y, and zoom, and we're going to adjust them in a little bit. So for the X value, you're actually going to want to put X plus world X, because you want to add on top of the position that you're already at based on your GPS. And you're going to do the same exact thing for Y, and be plus world Y. As for zoom, we're just going to take what we had earlier, the coefficient zoo to the power of zoom. That will make it so you can zoom in faster when you're further and slower when you're close. Next thing we want to do is actually find the position of the player. So you're going to go back up to help and copy the equation for pixel X and pixel Y. Paste that in and let's start changing the values. So as for map X, you're going to paste the same values we used for draw map. So X plus world X, and map Y is going to be Y plus world Y. Zoom is also going to be the same, just put zoo to the power of zoom. Screen width and height are going to be 64 and 64 because we're using a 2x2 screen. And you could leave world X and world Y as they are. Next thing you want to do is actually draw the player, so I'm going to paste in some commands. The first one you can see is we're going to change the color to something like a dark red. Then we're going to draw a small rectangle centered on the player. Set the color to a brighter but more transparent red. Then we're going to draw a bigger rectangle around the previous one. Then we're going to set the color to white. And finally, we're going to draw a little tiny circle at the very dot where the player is situated. The next thing we're going to do is actually draw those blacker, more transparent stuff under our controls. So we're going to set the color to something really dark but transparent, draw a big circle under the keypad, and then draw two rectangles under the coordinates and zoom controls. Again, notice that I am using my own coordinates here. These do work for my screen, but you can change them up for your own. Next, we're going to pick a color that is pretty good for drawing and text. So in my case, that will be something pretty white and transparent. Then I'm going to go ahead and draw my text. So I'm actually going to go into help and copy paste the draw text command. Just paste it in there. And again, I have my own predetermined coordinates that I'm just going to put in. And for the top, I'm going to put math.floor of world X and bottom math.floor of world Y. Now the math dot is actually referring to the math library inside Stormworks, and the floor function is something that takes the largest integer smaller than the value of world X or world Y. So that way we round off the decimals. Once we're done that, in the same exact color, we are going to draw the two rectangles for zoom in and zoom out, and these are going to have the same coordinates as our zoom in and zoom out buttons from onTick function. Now we want to draw those dark red squares that appear on the buttons when they're pressed. So we're going to start with an if statement, and we're going to go up to our onTick function and copy is pressing zoom in. Go back down, paste that, space then, and we are going to put a space and end. Same thing, except now we're going to write zoom out. And I'm going to paste some code in there. It's going to change the color to something a little darker. Draw a rectangle with the same coordinates, but notice that now it's rect F, so it'll be full. And set the color back to the regular one. Same thing for zoom out, except I'm going to change the coordinates again so that it fits the zoom out button and not the zoom in one. Now in our right color, we are going to draw 4 lines, one for the minus, one for the plus, and one for the zoom indicator. To complete our zoom indicator, we're going to have to make that little knob that goes up and down based on where the zoom value is. So the first thing we're going to do is set the color to something a little bit darker like we did before. So 50-2 is going to be a pretty good color. Also, I'm going to set the transparency to 150. And then I'm going to paste in the equation for that knob. As you can see, I wanted to have a width of 6 and a height of 3, and it's going to go start at X is 59 on the screen, and the Y is going to be the only thing that'll change. So that is actually going to be our zoo to the power of zoom coefficient times 19/50, because 50 is the actual range of zoo to the power of zoom, and 19 is the range we want it to have on the screen. Of course, we could change 19/50 to its decimal value of 0.38. Now, the next step is to use our writing color to draw the movement pad with the 4 arrows on it. So as you can see, I've changed the color back to 100, 100, 100, and 200, and I've drawn 4 rectangles, and the coordinates I already know, so I've just pasted them there. Now we're going to do the same exact thing that we did with our zoom in and out controls for these ones too. So we're going to write 4 if statements, and if that button is pressed, we're going to set its color to a dark red and make it a full rectangle. So it won't just be an outline, it'll be full of a deeper red color, and that will indicate to the user that they're actually pressing something. Now once again, in my if statement, I am writing to set the color to something a little darker, and I'm going to copy the corresponding rectangle. So for X plus, that is going to be the rightmost one, and then I'm going to set the color back to our writing color, which is 100, 100, 100, and 200 transparency. Then I'm going to hit enter and end, and I'm going to do the same exact thing for the other 3 buttons. We're almost done now. All that's left is to draw little triangles that will go inside of the movement buttons. So I'm just going to paste that in there. It's 4 draw triangles, and I already have the points all figured out there. I'm going to hit check for errors to make sure it doesn't recognize anything. And that should be it for the scripting part. Alright, so we should be finished just about everything. Let's go ahead and save our microcontroller to something like Interactive-Map 2. I'm actually going to save it because I already have one of these, and I should probably go into properties and rename it to Interactive-Map 2, because the properties is the actual name that it will give it in your menu. And we can go ahead and exit into the workbench, and we can start by building a little base to test this out. So just nothing special, a little bit of a base. We're gonna go get a medium electric battery, as well as a monitor 2x2. That's very important because that's what this map is designed for. We're gonna get a small keypad for our brightness. We're also gonna get a button. So we're gonna go ahead and grab a push button, just place it right there. We're also gonna need a large keypad just to enter in our coordinates, as well as the microprocessor that we just built. So I'm going to go into menu, and I'm going to search up Interactive-Map 2. Right there it is. Grab that, place it right there. All right. Now I'm going to go wire everything up, give it some power, and go into composite, connect the touch input, head on into video, connect the video output. Then I'm going to go ahead into data, and I'm going to connect the button to the monitor and to the microcontroller. I'm going to connect the small keypad to the brightness, which should be in the middle, and output A from the large keypad should go into the X coordinate, and output B should go into the Y coordinate. Now that should be everything, I think. I'm going to go ahead and name a few things really quickly. Alright, and we can go ahead and spawn this in and test it out. So spawning it in, let's go ahead and try to get this on. We're going to turn the button on, and oh, oops, I have put a push button. Alright, let's go ahead and change that to a toggle. Just going to search it up and wire it up to the rest of the components, just like we did with the push button. We go into the monitor, into the microprocessor, and give it some juice. Spawn that in. And turn it on. Gonna give the brightness 1. There we go. You can see our map is generated on the screen. We can zoom in and out. Everything seems to be working. You can see the little red indicators when we press it. We can also move around. That's very nice. We can see our player there in the middle. And our position is set to 0, 0 because we haven't changed it yet. So let's go and give it 2020, and it should change. There we go. On the island, it is also changed, moved a little bit. So that seems to be working too. Alright, looks like we have gotten this map to work. And let's see just a little bit how far we can zoom out. And you can see when we're zoomed out all the way, just how fast we can move. And that is so important. If we didn't implement that exponential function in our code, it would be incredibly slow to get from island to island. It would just be impossible. So it looks like everything's working. Everything seems to be good. Thank you guys so much for watching, and stay tuned for more videos.